So example number 1. A steel circular rod with a radius of 10 centimeters is placed between two vertical supports at 15 degrees Celsius. What compressive force is exerted by the vertical supports if the temperature increases to 40 degrees Celsius? Coefficient of linear expansion for steel is 12 times 10 to the negative 6 per degree Celsius, and the elastic modulus of steel is 200 gigapascal. So let's start with drawing the figure. So let's draw the figure, and this one, this is our material, and according to problem that we are supporting the material with vertical support. So here, not a vertical support. It should always be a kanang fixed support. Okay, and then it is 10 centimeters. No, not 10 centimeters. Pila yung length niya? Wala. So let's just consider the length L. Okay. So since according to problem that there is there is an increase to 40 degrees Celsius ang temperature, so mo expand ang atong material kay init man, no, from 15 degrees Celsius may mo siyang 40, so niinit ang atoang temperature. So ang pasabot ana mo expand ang atong material. So instead of having this original nga position, then somehow ako lang i-exaggerate ang pag-expand sa atong material. Something like that ang pag-expand niya. So from the original nga position kay diri naman gyud na dapat ang atong support here. From here, this is the support. So as you can see, na ni protrude nga mga nga member na to or length na to tungod sa increase sa temperature, pero exaggerated lang na, no? But because of the support are rigid, so the tendency here kay ang ato ang support kay mo give o internal force, compressive force in such a way nga sa tawag ani dili mo expand ang atong material, or like magpabilin lang siya nga length L. So that's the action of our support nga iyang i-push inside ang atong length nga material L para dili siya maka-expand og maayo. So that's the compressive force nga gipangita sa problem. So how do we solve that force F, compressive force? So let's just go back to what we've learned, that strain, we cannot actually use the formula katong thermal deformation T linear expansion delta T times L, because in the beginning wala tay L, and then although not tay change of T, but we don't have this one. So unsa man nato siya pag solve? So here's what we're gonna do. From the beginning, we have the modulus of elasticity to be the fraction of stress and strain, and then that stress is P over A, and that the strain is delta over L. So para ma-solve siya, we have E equal to P over A times delta over L. Oh, no, not times, but divide. So, kung ato na siyang i-multiply, that's L over... kung ato siyang i-multiply, that's L over delta. So, that is now P L over A delta. And then delta times E times A is equal to P times L. But let's go back to this one. We're talking about temperature. So, gonna have this relationship that the deformation is equal to the thermal deformation, and that is equal to alpha times delta T times L. So therefore, we can now have this as alpha times delta T times L times E times A equal to PL. Then remember that we can cancel out the L here. And of course, this P is the axial force. So therefore, P is just equal to the F in the problem. And so now, we will have F equal to thermal expansion times delta T times E times A. So let us substitute. We have, what is our thermal expansion? That's 12 times 10 to the negative 6. So that's 12 times 10 to the negative 6 per degree Celsius. And then our delta T. So our final temperature is 40 degrees Celsius minus initial is 15 degrees Celsius. And then our modulus of elasticity, according to problem, it is 200 gigapascal. So that's 200 times 10 to the 3 Newton per mm square. That's 200 gigapascal. And then our area, we have a given radius of 10 centimeters. So radius, 10 centimeters. So kay radius man ang given, that's pi r squared. So that's pi r squared kung given ang radius. So that's pi times r, 10 centimeters, or that's 100 millimeters. And do not forget that we're going to get the square of that. So ato sang isibog. So this one ato sang i-reason. So this is now to be multiplied by pi times 100 mm square. So our force now is equal to that function. So let me get my calculator. That's 12 times 10 to the negative 6 times 40 minus 15 is 25 times 200 times 10 to the 3 times pi times 100 square. So our answer here is 1884955.592 newtons. Is this newtons? Yes, newtons na siya, kay makancel out man atong degree Celsius diha, and then makancel out sad nato ang mm square. So ang magpapilin kay newtons. So this is somehow ang F nato, ang F, it could be F equal to 188.4 996 no 956 kilo newtons. And this is our final answer. The compressive F force nga mo push sa kaning sa material para dili siya mo longer. That's our example number 1.